All right, welcome back everyone. Today we're going to be looking at part 3, which is systems of equations by elimination. Once again, we're going to be focusing on the second learning target. I am learning to solve systems of linear equations algebraically. So when solving systems by the elimination method, you're either going to multiply one or both equations by a number to result in two equations that contain opposite terms. Then you're going to add the equations, eliminate one variable, then solve the equation, and then substitute to solve for the other variable. It's actually quite easy. So a couple tips and tricks. You either want to be looking for variables that are already opposite or can easily become opposite if I multiply by -1. So here we have a 3y and a 3y. If I were to multiply just one of these equations by -1, it would change every property of that equation. So this actually ends up becoming -5x minus 3y equals 19. Then we have 8x plus 3y equals -25. Now, because these are already opposite, we can end up canceling, and now we add straight across. -5x plus 8x is 3x equals 19 plus -25, which is -6. Our goal will be to isolate the x, so we're going to divide both sides by 3. And we get x equals -2. We're now going to substitute x equals -2 into the equation we did not mess with. So in this case, it's equation number 2. So we go 8 times -2 plus 3y equals -25. -16 plus 3y equals -25. Going to add 16 to both sides because our goal here is to isolate the y variable this time. We now get 3y equals -9. Divide both sides by 3, and we get a beautiful answer of y equals -3. Our final answer becomes the xy. Our x was -2, our y is -3. All right, let's go on to the next example. Once again, I either want to look for variables that are exactly the opposite or can be made exactly the opposite quite easily. So in this case, we have these two -5's. And once again, all we're going to be doing is multiplying one equation by -1. And that's going to change every property. So I now have -6x plus 5y equals +8. We did nothing to the second equation, so we're just going to bring it down. And we're going to add straight across. -6x plus 4x is -2x. The 5y's cancel. Now we have 8 plus -12, which is -4. Once again, our goal is to isolate that x variable, so we're going to divide by -2. So x equals +2. We're going to substitute that x equals +2 into the equation we did not manipulate. In this case, it is equation 2 once again. So we have 4 times 2 minus 5y equals -12. So I have 8 minus 5y equals -12. I'm going to subtract 8 from both sides. I have -5y equals -20. Divide both sides by -5. We get y equals a +4. And so once again, our answer is in xy terms as an ordered pair. So we get 2, 4. All right. The next example is not quite as easy because we don't already have terms that are already exactly opposite or exactly the same. We need to figure out if any of our terms can go into another term. So looking at our numerator, we have 5x plus 3y equals 52. And in our second equation, we have 15x plus 9y equals 54. Can 5 go into 15 or 3 go into 9? Ding, ding, ding. If you said yes, you are absolutely correct. And what number do you think that would be? 3. 3 is correct. So our first equation, if we multiplied it by 3, would get us exactly 15x, exactly 9y, and exactly 156. However, we want opposites, so we're actually going to be multiplying by negative 3. So now we have negative 15x, negative 9y equals negative 156. We did nothing to the second equation, so we're just going to rewrite it down. 15x plus 9y equals 54. Cross out, because they were already opposites. We get 0 equals negative 102. Is that even possible? Can 0 equal negative 102? The answer is no. So there is no solution. All right, let's go to the next one. Can 2 go into 4? Absolutely. How many times? Twice. And because 4 is already negative and 2 is already positive, we do not have to change the signs. So now we have 4x plus 6y equals 30, and minus 4x minus 6y equals negative 30. If you've already done this math quickly, you'll notice boom, boom, boom. In this case, 0 equals 0, so we have an all real numbers solution. All right, if you have any questions, please feel free to email me. Have a great day.